The sky has always carried secrets beyond human comprehension. Secrets so vast, so overwhelming that even the greatest minds in history have struggled to grasp them. Every answer humanity discovers seems to open the door to 1,000 more questions. The deeper we look into the cosmos, the more mysterious it becomes, as if the universe is designed not to be fully solved, but endlessly explored. For countless centuries, human beings have lifted their eyes toward the night sky. Long before telescopes or satellites existed, ancient civilizations stood beneath the same blanket of stars we see today, trying to find meaning in the silent patterns above them. To them, the heavens were not empty darkness sprinkled with light. They were a sacred map, a living canvas filled with destiny, memory, and invisible order. Across cultures and continents, people connected the stars into constellations, weaving distant points of light into stories of gods, heroes, and cosmic creatures. The sky became a stage where legends unfolded. Kings consulted it before wars. Sailors crossed oceans guided only by its patterns. Entire civilizations built calendars, temples, and rituals based on celestial motion. The stars were not just objects. They were guidance, prophecy, and mystery combined. Ancient philosophers debated endlessly about their nature. Were the stars eternal and unchanging, perfect lights fixed in a divine structure, or were they born, evolving, and destined to die like everything else in the world? This question echoed across generations, forming one of humanity's oldest scientific mysteries. Then came a turning point, the age of observation. When early astronomers began studying the sky with instruments instead of imagination, everything changed. Galileo turned one of the first telescopes toward the heavens and revealed a universe far more complex than anyone had imagined: moons orbiting Jupiter, mountains on the moon, and countless invisible stars. Later, Isaac Newton described the force that governed it all: gravity. Suddenly, the sky was no longer mysterious poetry alone. It became a system of laws, forces, and predictable motion. But the deeper humanity looked, the more uncertain reality became. Stars were not eternal. They were born in vast clouds of gas, lived for millions or billions of years, and died in violent explosions or quiet collapses. Galaxies stretched across unimaginable distances, and black holes warped space itself. The universe was not simple. It was layered, evolving, and far more dynamic than early science expected. In the 21st century, humanity built one of its most powerful tools for exploring this cosmic depth: a space observatory designed to see farther back in time than ever before. This instrument is not just a machine. It is the result of decades of global collaboration, engineering precision, and scientific ambition. Built and tested over many years, it was launched into space and positioned far beyond Earth, where it could observe the universe without atmospheric distortion or light interference. From its distant orbit, it collects faint infrared light that has traveled across billions of years. This allows it to see objects not as they are today, but as they were in the ancient past, when the universe was still forming its first structures. In many ways, it functions like a time machine. Every image it captures is a glimpse into deep history: ancient galaxies forming, newborn stars igniting, and cosmic structures assembling long before Earth existed. Since its deployment, it has transformed our understanding of the universe. It has revealed stellar nurseries where stars are born inside dense clouds of gas and dust. It has captured galaxies colliding in slow gravitational dances that span billions of years. It has even studied distant worlds, analyzing their atmospheres for signs of chemical activity that might hint at the possibility of life. But alongside these discoveries, something unexpected has emerged. When astronomers study certain regions of the early universe, they notice inconsistencies in the expected number of visible stars. According to long-standing models, There should be significantly more observable stars in certain eras of cosmic history than what current data reveals. In fact, large populations of stars appear to be missing from observations. These are not stars destroyed in dramatic explosions. There is no clear evidence of widespread supernova activity explaining the gap. Instead, something more subtle seems to be happening. They are simply not visible to us. One possibility is that these stars still exist, but are hidden behind vast clouds of interstellar dust. Even advanced infrared observation has limits. Dense regions of cosmic material can absorb or scatter light so effectively that entire stellar populations become invisible. Another explanation suggests that many of these stars may have already evolved beyond their luminous phase. Stars do not shine forever. Over time, they exhaust their fuel, shrink, cool, and fade into dim remnants such as white dwarfs or neutron stars. There is also a more extreme possibility. Some stars may have collapsed directly into black holes without producing the bright supernova explosions typically associated with stellar death. In such cases, the star would effectively vanish from direct observation, leaving only its gravitational influence behind. Yet even combined, these explanations do not fully account for the scale of the missing population. The discrepancy remains large enough to raise deeper questions about how stars form, evolve, and disappear across cosmic time. To understand this, scientists turn to one of the most important discoveries in modern cosmology: the expansion of the universe. In the early 20th century, it was discovered that distant galaxies are moving away from us. The farther a galaxy is, the faster it appears to recede. This revealed a profound truth: space itself is expanding. Later, an even more surprising discovery was made: this expansion is not slowing down. It is accelerating. This acceleration is attributed to a mysterious force known as dark energy, which appears to make up nearly 70% of the universe's total energy content. Alongside it exists dark matter, an invisible form of mass that does not emit light but exerts gravitational influence. It helps hold galaxies together and shapes the large-scale structure of the cosmos. Together, dark energy and dark matter dominate the universe, leaving ordinary matter, the atoms that form stars, planets, and life, as only a small fraction of everything that exists. Because of dark energy, galaxies are gradually moving farther apart. Over immense time scales, many will cross a boundary beyond which their light will never reach us again. This is known as the cosmic horizon. Beyond that horizon, entire galaxies effectively disappear from our observable universe. They are not destroyed. They simply become unreachable, light-stretched and lost across expanding space. This means the night sky we see today is not a complete picture of the universe. It is a snapshot of the past, a fragment of a much larger and constantly changing reality. Many of the stars visible above us may no longer exist in the form we observe. Their light is ancient, traveling across billions of years to reach a small world that is itself constantly moving through space. This realization changes everything. The universe is not static. It is not fixed. It is evolving, expanding, and gradually becoming more distant from itself over time. Galaxies drift apart. Stars are born and die. Entire regions of space slowly slip beyond our reach forever. Yet within this vast and changing cosmos, humanity has achieved something extraordinary: the ability to observe it. Through advanced instruments, we can detect photons that began their journey billions of years ago. Each observation is not just an image, it is a message from the past. Every dataset, every deep field image, every spectrum of distant light is a piece of a cosmic puzzle that stretches across time itself. The mystery of missing stars reminds us that our understanding is still incomplete. It suggests that there are processes at work in the universe that we have not yet fully uncovered, hidden structures, unknown phases of stellar evolution, or perhaps even entirely new physics. Future discoveries may reveal hidden populations of stars. They may refine our models of cosmic evolution, or they may reveal phenomena we have not yet imagined. Whatever the answer turns out to be, the search itself defines us. Because in a universe where stars fade, galaxies drift apart, and even light eventually disappears beyond the cosmic horizon, the act of looking, of questioning, becomes something far more significant than simple observation. It becomes a connection between a curious species and the infinite. And as long as there are eyes turned toward the sky, instruments built to extend those eyes, and minds willing to ask what lies beyond, the universe will continue to reveal itself, one discovery at a time.